Hi, it's John again, and I have with me this Cypress PSoC6 BLE Pioneer Kit that came to me via Element 14 with their RoadTest. I submitted, and they actually had some extras towards the end there, so they sent me one, and I'm going to give this thing a whirl and check out some of the features with it and run through some examples. This is a really cool device that Cypress has put together. It has their PSoC6, their latest PSoC device. It has 2 cores on it. It has a ARM Cortex M0 and ARM Cortex M4. It also comes with this handy dandy little touch sensor over here. So this is their CapSense touch sensor. Has a slider and 2 buttons over here. It also has a proximity sensor. That's what the header's for. And they come with a series of jumper wires, and you can do something like this, put it in a loop and put it inside there and use it as a proximity sensor. I'll show that in an example later. It has an RGB LED, has some memory, has the USB, has a BLE, or actually BLE with the antenna right there, has Arduino headers that are on there, and that's what this LCD is connected to. And this is a e-ink LCD, and the LCD also has a motion sensor, thermistor, and a microphone. We'll show that microphone a little bit later. And also on here you have, it's not populated, but it has a header, or at least you can put a header on there for a battery, so you can run it off like a LiPo battery, which is handy. And it also has this Type-C USB connection, so that's something new. And it has a kit tube prog for the programmer, and for loading it and doing all sorts of good stuff with that. But it also can be used to power up that and charge that that battery if you have it plugged into. It has a couple headers over here if you have a J-Link, if you want to do some debugging with it. There's some examples out there for Tracealyzer, for actually debugging RTOS on top of this. So you can actually load free RTOS on here. That's another one of the examples. So I've been going through a series of examples that have been on the web for the PSoC6 101 that were put together by Alan Hawes. And so I'm going to show basically one of the examples on here, and how to get this thing to Blinky, which is seems to be fairly easy compared to some other devices. And in this particular one, I'm just going to go ahead and show how to do it via hardware. I have a PSoC Creator, which is their IDE tool. And to get this installed, this is still, I believe, in beta. It comes off their forum. I installed Creator 4.1 complete, and then install this complete, and that seemed to install fine. And I noticed that there's some people were having problems with it, so I tried that. I didn't have a problem with it. It seemed to go up and get installed and run pretty good, and it had to update the firmware and did that, and everything seemed to be running fine. It comes with a kit that you can download, which has a bunch of examples. So this is some of the examples that it came with. They're also on their website. You can download other examples. And these actually go into, C, it goes under C here, this firmware here. So the examples end up here. You can put them elsewhere if you like, but when you install the kit, this is actually where it puts it. So this has the UI, BLE UI, which is the out-of-box example that they have for checking out the BLE stuff. And then the thermometer, which is going to test out the thermistor. Proximity, we'll go through that later. And then there's a CapSense and a whole bunch of little examples that they have. I did have some problems with some of them, and maybe I'll have to point that out later on. So I've been running through some examples, and what we'll do is we'll go ahead and create one. We'll create a program for this. So we go to New Project. We'll create a new project for this. This is actually the device name, but the examples I see, just use that. So we'll just go ahead and try that. And then here you can go and use code examples, pre-populated schematics, or just an empty schematic. So we'll just use the empty. Go next, and then just take the defaults here. I'll just go ahead and leave that. Actually, no, I'm going to go ahead and create a new one. Let me go back here. Create that. I'm going to put this in a different location. We'll just put it there. We'll call this, oops, PSoC6 RoadTest. Once you click finish, it'll go ahead and create this basic outline here. So it gives you the basic hardware features, the top design, and then your pins and your analog stuff. And then for the two different cores, the ARM Cortex-M0 and the Cortex-M4, it just adds in some placeholders for the folders and stuff like that, and just the basic main file here. It really doesn't have much inside of it. The 0 is set to enable the Cortex-M4. We'll go ahead and disable that. We'll show that a little bit later. And it doesn't find this because you haven't loaded the code yet. So if we go back to the top level design, I'm going to zoom in on this so it's easier to see. Over here, you have your component catalog on the right-hand side, which has all the different components you can add on here. You've got analog devices like ADC and amplifiers. Has a cap sense. You can go ahead and add that. Some communications for your Bluetooth and the PDMCM. I'll show that example later. I actually ran into an issue with that trying to get it loaded. But we'll go down here. The ports, we're going to add a digital output pin for one of the LEDs. We'll double click that. We'll bring it up. We'll change that to red. And we'll leave this to a hardware connection because we're going to run it through hardware. If you are going to run it through one of the ARM cores, then you'd go ahead and disable that. But we're not going to do that here. We're going to come up here to digital functions. We're going to add this PWM module. Drag that over there. And we're going to double click that. Now the name is important because the name is what it's going to use when it builds the interfaces and all the software for this. The example I seen just said PWM. I'm going to leave it PWM1 because I want to show you what happens with that. Because if you can't find your code and you have a problem with that, it might be because of the naming convention here. So you have to be aware of that. So I'm going to change the period to 1000 and the compare to 500. And that's all we got for that. And then I'm going to come down here. And then we're going to add a clock. We're going to snag that right there. Double click it. Change that to kilohertz. And leave everything else by default. And then we need to connect the PWM to the LED. So if we click over here, you have a series of different, like you see in, don't know why it's moving. I really don't. So something happened with my mouse, I guess. Oh, did I click something? I guess I did. That was weird. Okay, so we want to get a wire. So we got the wire here, and we just want to connect these two guys. So that should be connected. So now we have our clock, we have our PWM, and then we have our red LED. And the last thing you have to do is you're going to have to come up here to the design-wide resources. If you double-click that, you'll get to see the chip here and all the connections and stuff. And then over here on the right-hand side, you get to see our red LED. And but we have to assign it a port and pin. So if you go ahead and click that, you'll get this drop-down menu. And for the red LED on the RGB, it's assigned to P03. So port 0, pin 3. And so that will do that. And once you've completed that, go ahead and save it. Save all of it. You come up to build, generate application. And what this is going to do is going to build the application. It's going to build the interfaces for all your hardware devices that you put together here. For the clock, for the PWM, for the red LED. So it's going to create all that, the firmware and the code and everything it needs to run those. And you'll see this on the left-hand side. You'll see these will populate all of a sudden with all that code. And so we get to use that later on once it completes. And if you need to add more devices to it, you'll go ahead and add the devices. Then you have to go back through this process again. And so it can build all those interfaces. And then you can go back and manage them later. So this thing should be almost done. It's almost there. It keeps moving. And so, yep, not the quickest thing in the world, that's for sure. I don't know if that's because of my PC or whatever, but it's cleaning up, and there you go. Yep, so we have a whole bunch of code that's up now. So it's shared files, we got the PSoC, we got our PWM, if you notice the name, and then our pins and interrupts have been populated. The clock has been populated. So like a PWM creates our interfaces that we need. So that's pretty cool. So what we're going to do is we're going to come up here to the Cortex-0. So if you notice, it's got the Cortex, so it's got the M0 and the M4. And we'll go into the main for this. This should go away. Yep, so now it found its project. And we're going to go ahead and comment this out because we don't want the M4 running at this time. And then we're going to come down here. We're going to do PWM. Now, this is the thing I was talking about. So because of the name that I named the PWM module, this is what the interfaces show. So it's PWM_1. So that name you have to be aware of. So I got a 1 and then a start. So that's what I'm looking for. So this should start the PWM module, the code for that. Then I'm going to add a Cypress not just PM sleep. So what this will do is this will put the Cortex M0 to sleep. So it's not running. If I can type right. Status. So we're going to check the status sleep. And that's pretty much it. So this will start the PWM, and this will put the M0 to sleep. And then over here, we prevented the M4 from launching. So this all should be running on hardware when it's done. So we go back and save it. We'll go ahead and build it. So now it's going to build all that. It's going to add in all the code that it had. It needs to run with the hardware pieces as well as this. And if we look down here, so we look at the main for the C4, it's really got nothing inside there, just enabled IRQ and then a super loop. Go back to our Cortex M0. So it's going. I believe it's done. It's got one warning. This is a warning for a truncated to unsigned. So this is their code. This isn't what I put inside here. So that might be something that they want to address if they want to get rid of the warnings. We got no errors in the output. Build succeeded. So at this point, we should be able to go up here. This little button right here says program. Should go ahead and program the device. Not quite sure. And there you go. So now we have the Blinky LED right there. So, and so now it's running off the hardware. So it's not going, technically not going through one of the cores. It's going straight to the hardware. And that's how simple it is to get the Blinky. And so you can use the same sort of concept and then add in other features. Something else I want to try to do, I want to try to have this power some motors and maybe put it onto a robot frame and have it move around and add some sensors on it and stuff like that. And but that was pretty simple. And so that's how you get the Blinky through hardware with the PSoC6 on the BLE Pioneer Kit. So that's pretty much it.